In this section, we will discuss what each data layer displays in the list on the left side of your screen. Data layers can be turned on and off by checkmarking the box on the left side. Going from the bottom of the list to the top, starting with the Map Inset. The Map Inset layer has been included to provide an aerial locator of your position within the state of Kansas. As you zoom or move around the state, the Map Inset continues to update with your existing position shown graphically on the lower right portion of the screen. As you can see, this is automatically turned on when the tool starts up. As I mentioned a moment ago, you can turn these data layers on and off by checking and unchecking the box to the left. I'm going to turn the Map Inset off by unchecking the box. Next is the 3D building layer, which allows you to see three-dimensional images such as buildings and may be turned on to add realism of the model that has been created. However, 3D buildings are not available in all areas of the state and are determined by Google Earth. The next layer is Victor Airwaves. When turned on, this layer shows the airways for aircraft using point-to-point navigation. These routes are typically located between 1,200 feet and 18,000 feet mean sea level. Next is the obstructions layer, which provides the available structures around the state of Kansas, whether they are obstructions to air navigation or not. These structures may include water towers, communications towers, wind turbines, or buildings. The next layer is special use airspace. With this layer turned on, you will see surfaces that include restricted areas that are shown on the map to illustrate its location in the state of Kansas. Special use airspace is an area reserved for certain flight activities that must be confined to their nature or where limitations are imposed on aircraft operations that are not a part of those activities, or both. Typically, this airspace has a floor-ceiling boundary and operating hours for which these restrictions apply. The restricted areas are controlled by the FAA, and aircraft are prohibited from operating in these areas during certain hours and altitudes. Next, you have the U.S. Sectionals layer. When turning on the U.S. Sectionals layer, you may see red X's pop up on your map. Don't worry, just go over on top of your map and then zoom in a bit, and the red X's should go away. The current U.S. sectional map is overlaid on the Google Earth for reference. These maps are used by pilots to navigate from point to point and depict airports, nav aids, obstructions, dominant land features, radio frequencies, and other air navigation information needed for safe flight. Then, you have military training routes. The military training routes are shown inside the special use areas in the state. These low-level routes are reserved for high-speed, low-altitude operations. Next is the Contacts for Vicinity layer. When the Contacts for Vicinity layer is turned on, you can hover over any of these circles, click on one. When clicked on, it shows you each airport's contact information, such as the name, owner, phone number, and any other information available. Next is the vertically guided airspace surface. These surfaces are separated into runways with vertical guidance and runways without vertical guidance. When the vertically guided airspace layer is turned on, you will then need to zoom into an airport to fully see the surface layer. Once you zoom in far enough, you should then be able to see the surfaces. These surfaces are used by the FAA to guide the new airspace obstruction surveys that provide a rigorous analysis of all the objects within an approach surface. The next data layer is the CFR Part 77 airspace surface, or imaginary surface. When turning this layer on, you will need to go and hover over an airport and zoom into that location in order to see the surface. In this case, I'll zoom into the Hayes Airport. With this layer turned on and zoomed in, you can see it consists of the approach, horizontal, conical, and outer transitional surfaces. And last but not least is the generalized terp surface. After turning this layer on, you will need to zoom into an airport to better see the surface layer. In this case, I will zoom into the Hayes Airport. So with this layer on and zoomed in, it illustrates the approach surface requirements. These surfaces are separated between approach runway ends, expected to accommodate approaches with positive vertical guidance, and runways expected to accommodate approaches having visibility minimums less than 3/4 of a mile.